Hello students, so in this question it asks us at the 5,800 meter mark, the sled in the previous question, so 43, begins to accelerate at -7 meters per second squared. Use your answers from question 43 to answer the following question. So we have to refer to the previous question. What is the final position of the sled when it comes to rest, and how long does it take for the sled to come to rest? So let's visualize this a little bit, and I'll remind you of the previous question. So on the velocity versus time graph, you had the sled come up here and then go over. Well, this was T1, if you remember right. And at this point, we marked that as the change in X1. And then this mark was the change in X2. This total distance here was 5,300 meters. 5,300 meters. Now, in this question, in this next question, we're saying the sled went a little bit further to 5,800 meters, right? So the total here is 5,800 meters. Before this sled begins decelerating, and we want to know how long it takes for it to decelerate to rest and how far it travels during that amount of time. So we want to know what this change in X is here from this point to this point, and then we want to gather some information here. The first value I want to write down is the velocity initial, and we know that from our previous question, which is about 60 meters per second, all right? And then our velocity final is what we're trying to get to, see what the distance is for that velocity final, so when that sled comes to rest. So what would our velocity final be if it came to rest? Well, that's 0 meters per second, right? And then we have our change in X is what we're trying to find. So what is the distance that it travels from 60 meters per second when it gets down to that 0 meters per second? And then we know the acceleration. The acceleration or deceleration is -7.0 meters per second squared. So now that we have all of our information, we need to find an equation that helps us out with that. And here is the equation that we're going to use. Velocity final squared equals velocity initial squared plus 2 times the acceleration change in X. And this should look fairly familiar to you. All right, so let's go ahead, and our velocity final is 0. Our velocity initial is 60 meters per second. However, we're going to square that plus 2 times our acceleration, which our acceleration is -7.0 meters per second squared, and then we can figure out our change in X. I could have rewritten this to add in 5,800 as my initial starting point and then my final, but I'm just going to put the change in X and just refer to this distance right here, and then I'll add it back in. So go ahead and work that out, and then this should give you the change in X equals about 260 meters. Now if you add that to 5,800, that'll give you your total distance traveled before it comes to a stop. And when you add that, your total distance would be 6,100. So your total distance, equals 6,100 meters, or about that. All right. So let me pause the video for a second, and I'll go on to part B. In part B, what I'm going to use is this equation right here in order to figure out how much time it took for that sled to come to a stop from its point at 5,800 meters. So the velocity final, if you remember from the previous question, was 0. And then its velocity initial was 60. And its acceleration or deceleration was -7. and then you can solve for time that way. So if you work this out, it should come out to time equals 8.6 seconds. So something around there. Alright, and that's it for this question. I hope this helped out. I'll see you guys in the next Zoom meeting.